Hello, welcome everyone to today's webinar, which is entitled Setup and Walkaway, High-throughput DNA Purification and Targeted Genotyping by Sequencing with Automated Liquid Handling. I'm Thomas Winkemüller, Product Manager for DNA and RNA extraction at LGC, and I will be the moderator of today's event. Today is an educational webinar which is presented by LabRoots and brought to you by LGC Biosearch Technologies. And in case you want to learn more about our products, please feel free to take a look at biosearchtech.com. As this should be an educational webinar and you should all benefit from that and having the chance to speak to an expert from the field, we highly encourage you to participate in today's webinar by submitting any kind of question that may pop up during the presentation. To do so is fairly simple. So you should be able to see a small ask a question box and you can simply type your question there and click send. We will try to answer as many questions as possible during the presentation. And we will also have a live Q&A session after the presentation. So yeah, we are really happy to get as many questions as possible and discuss them with you. In case we will not be able to answer the question in the time or in the live Q&A, don't worry. We will make sure to get back to you then via email and make sure your question will be answered. If you have any or if you experience any technical issues, you can also just utilize the Q&A box and we will assist you to get that solved. Last thing that I would like to mention is that we would have interactive poll question coming after the webinar. So we highly appreciate if you take a minute to participate in that. And without doing much more talking, I'm super happy to welcome the speaker of today, Toby Sangel, which is the sales and application manager for the Western US and all international accounts at Dynamic Devices. And I'm really looking forward to a very insightful presentation and learn more about automation. And with this, Toby, the stage is yours.
All right. Well, thank you, Thomas. I appreciate the introduction. As Thomas mentioned, I'm with Dynamic Devices and Sales and Applications Manager, but prior to that, I spent 7 years working in the lab for various agricultural companies, and so spent plenty of time in ag biotech. So I appreciate everybody's time today. Hope everybody learned something. Hammer us with the questions. I look forward to it, and I will get ready to get started. Turn my camera off on this bright, sunny day here in Iowa, and there we go. All right. Well, I am here to talk about the setup and walkaway of the Lynx system for the high-throughput DNA purification and targeted GBS on our system. And so with that, I will get started. So kind of a breakdown of how I'm going to talk about everything today is a short little intro about who we are and what we do. Our platform's called the Lynx, so I'll talk a little bit about just what that is and kind of how that looks. And then I'll dive right into our key technologies. So there's two that differentiate us from all the other players in the space. One's called the MCPA, the other one's called the VVP, and I'll get into those in more detail. And then after I talk about those technologies, I will go ahead and discuss workflows and applications that we actually use those in and kind of the strengths and nuances that those allow us to deal with. And then, of course, at the end, we'll have some Q&A. So a little bit about who we are. So we've been around a long time, a little over 25 years, founded in 1999. But early on, specialized in integrations and OEM solutions and developed several pipetters prior to our Lynx platform, just under different brand names. And so a lot of people maybe are wondering, hey, you've been around a long time, I haven't heard of you. But a lot of the pipetters that we put out in the marketplace were actually for customers that are now competitors in some cases. So we've been around doing this a long time. But what does it look like today? So today we focus on our own liquid handling solutions and OEM products. And we have manufacturing and operations based in Phoenix, Arizona, with a couple different North America field offices here in Des Moines, where I'm located, and then also in Boston. We have an R&D and support office for our European operations based in Switzerland. And then We do have a global presence that we work through some direct and then also distributor operations. So install base around the world. So this is the Lynx platform. So we have different chassis sizes, and that just a lot of it depends on what you want to do with the system. So do you want something that's working a very large, complex workflow, more of a simple workflow where you walk up to the system, hit go, and just start running? Or do you need to mix and match tools, and so you need a little more deck space to accommodate that? So quick overview of the systems, a little bit about each one. The LM700 is our smallest chassis. Of the tools that I'll be talking about today, it can have the MCPA, but it's limited on volume. So nothing greater than 300 microliters. It's a little bit shorter, doesn't have the clearance for our large volume tools. And it can't have the VVP technology on this platform. Once you get to the 730i, everything becomes available in terms of tools, no restrictions on volumes and things like that. The big thing to note here is it's wide open. It's really meant to be as part of a larger work cell or robotic integration. Doesn't have to be, but that's generally what we see customers use this for. The LM900 is the first one that allows all the technologies that we offer to be placed on a system with an enclosure. So this LM900, 30 deck positions, all enclosed. LM1200 is the first system that allows 2 independent arms to be operated on the same chassis, so they can operate concurrently or sequentially, just depending on your workflow. And then the LM1800 is the biggest. The thing that I like to point out to customers or people that are new to the Lynx system is that the price of the instruments doesn't really change much. So going from this LM900 to this system that's twice the size is only about $10,000. So it's not, it's more about the technology that you choose, not the size of the platform that really dictates things. So the first thing I'll talk about is the MCPA. So what is it? We call it MCPA because it stands for a multi-core processing arm. And what that means is it allows you to exchange different tools on the fly. So we have a lot of different options. Of course, we have multiple pipetting options, but really what makes us unique is not only can we do this on the fly, we can also incorporate things that are not traditional pipette tools, such as magnetic rods and a whole suite of other tools that I'll kind of go into in a little bit. The way that this is structured is it allows the system to kind of grow or expand as you use the system. So you can start with one tool, and then maybe your workflow changes or you add various parts to that workflow or want to automate more of it. And so you can add those tools, and it only takes about 20, 30 minutes to add those tools. So it's very simple to do. No real stress or challenges on the user to introduce those on their own. Also, it gives ease of service and redundancy. So PM, for example, we only need to take the system down for about 20, 30 minutes when we do a PM because we can take these cores, service them offline while another core of the same type is being used to actually continue operations for those high throughput labs that we work with. Very easy to use. If you can lift about 10, 15 pounds, you can lift any one of our cores in place and set it in its nest so it can be taken off or on the deck as needed. And then in terms of the command sets for the software, each tool just has a simple drag and drop unload and load tool command. So what do we offer for the pipetting? So we have a 384, 96, and 24. These are the basic ones that we offer. They give you a volume range when you incorporate all three of 0.3 microliters to 5 ml. So it's possible to have a very wide dynamic range on one system. Some other things I like to point out is we have additional cores that are very common, such as a 96 version of our 384. So you get the same low volume range, but in a 96 format. So this will be useful in an example that I'll show later where we are using the 384 to go into a 1536 plate. But if your source was a 96, you could also use that low volume 96 to go into that 1536 directly without having to have an intermediate plate. We have a 24 channel version of the 96, which is great for 24 well racks and tubes, and a 6 well version of this 24 channel for working in like 50 mil Falcon tubes in a 2x3 format. And of course, we offer a lot of customization and get new requests all the time for various plate formats. So this is just an example of that tool exchange in real time. This is what it looks like on the fly. This isn't sped up or anything, so it's about 30 seconds from the time that we hit go to drive all the way across the deck, put the tool down, pick up a new tool, and then be ready for whatever actions that we're going to request of that, whether it's loading tips. If it's a different tool, it may be loading a tip comb or going into a plate for a sample collection. And there we go. And now it's ready to go and perform the next set of operations. So in addition to the pipette cores, what really makes this a powerful solution, especially for the workflows that I'm going to talk about, is the ability to incorporate the magnetic rods, or what we call mag rods. So we have a 96 version, a 24, and then a 24 XL, which is used for very large volume applications, typically in the clinical setting. So these are like plasmid and cfDNA extraction purifications of 10 mil samples. The one that I'll be focused on today will be this 96. But what this allows us to do, it allows us to use a pipette tool, put that down, and then pick up this magnetic rod and begin things that are typically done on magnetic processors, where you'd have to go to a separate system to do this type of work or have a more expensive integration. These are very inexpensive to add to the system. So in most cases, these tools are going to be less than 10K. So rather than buying a whole new instrument, you can easily just add one of these to the deck and begin this type of workflow. Okay, so we have various specialized features for the magnetic rods. And one of them that I like to showcase and talk about is the expanded motion control that we have. Since we're using our standard Lynx gantry, we have full X, Y, and Z motion, not just limited to the up and down motion. So we can do more customized binding and mixing protocols, which in a lot of cases isn't necessary, but in some cases is very helpful for getting the best elution volumes, mixes, washes, binding for difficult sample types. So pretty much if it can be accomplished with magnetic rods, we have the tools necessary to do it. Another thing is the way that we do the loading of the tip comb allows it to be continuously fed. So you'll see here that we're doing what we call a slip load, where we can go in, load the tip comb, go do whatever we need to, and then slide it back off, which could go, in this case, it went to a depot plate, which can be fed on and off with a robotic arm, allowing that increased workaway time. Or it could be dropped into a waste chute directly. In addition to integration with robotic arms and things like that, we have the ability to have temperature control locations. So if you have that heated elution buffer, this is a good example of, we can have one, two, multiple locations, just depending on that configuration that you're working with. So it gives the user a lot of options. We also have the ability to process in parallel. So for those larger systems that have dual arms, it could be a pipette arm that's doing all of the prep work, lysate transfers, bead additions to the plates, getting all the wash buffers and things added. And then the magnetic rod's actually doing the purification and moving those magnetic beads through the different steps of the process. The other way to do it is we could have a dual mag rod system where all the plates are pre-prepped either in a previous method or on another system, come into our system fully loaded with all the reagents and buffers, and then you just increase your throughput for that DNA purification. So we have two tools going on at the same time. So some additional core options that we have for that MCPA, we have a positive pressure adapter, we have a pin tool, we have a patented purification tool for 50 mil Falcon tubes, and we have a lot of other unique things. So ampule breaking, nitrogen blowdown, seed crushing. I know my seed customers love that. And so with the MCPA, it's all about flexibility. When we come to the VBP, which is the next technology that differentiates us that I'll talk about, it's not just about flexibility, but it's also about data and the independent control that you're going to see, and how we can use these diagnostic features to streamline either processes and or increase walkaway time by reducing user intervention that's required for challenging sample types. So what is the VVP? Well, it stands for volume verified pipetting. In my history, I would say that most people think of it as variable volume pipetting because of the ability to have a different volume in every single channel, which is very helpful for processes like normalization, for example. But we also use that in a lot of different ways that allow us to do some very rapid pipetting actions such as pooling and cherry picking. And I'll showcase a couple of those as we go on. So what are the key benefits? So as in its name, we provide the volumetric data for every single transfer for every single channel. In addition to having the independent volumes that we can set for each channel has independent diagnostics. So rather than having whole head diagnostics or a group or bank of channels that are tied together, every single channel can report whether it has a clog, clot, empty well, it starts pipetting air, any of the diagnostic features that we offer, in addition to just reporting the volumetric data. And the head itself has a very large dynamic range for a single tool. So it goes from 2 microliters up to 1,250 microliters with excellent performance. So we have multiple different flavors of this. So the ones that differentiate us in the marketplace are going to be this 96 VBP and 24 VBP. Nobody else has anything greater than 8, or in some cases 2 8s together for a 16 for independent volume control. So this 24 and 96 really give us the ability to do a lot of unique throughput processes for our customers. We also offer an 8 and a 4 channel for that independent Z control, and then a fixed 8, just kind of a more budget-friendly option. As mentioned, all these diagnostics and features are going to be on the independent channel level. So the first one that I'll talk about is the clot and clog detection. So here's an example of where we are going to be aspirating a very challenging bovine sample. So there's a couple things that we're able to do. So we're monitoring the aspiration in real time. And as we're aspirating it, if there's a clot or clog detected, it shuts that valve off for that channel. And then it allows it to retry. And then once it performs that retry, we're able to get a feedback to say, did we clear the clog? Did we not clear the clog? And then based on how we set it up in the programming, it can retry up to 5 times. So here's just an example of kind of looking at it from a single tip view. What I like about it is it's a progressive process. So let's say we had 5 clots or clogs. When it's going through the process, if it clears 4 on the first try, it's only going to retry the remaining 1. At the end, if it's not able to clear it, the user has the option to put it back and move no volume forward, or take that partial aspiration and move it forward with the volumetric data reported. I came from agriculture, and we had a lot of difficult sample types. In particular, we had some like root tissue, for example, that on our other liquid handling systems would have a 30 to 40% failure rate when we would transfer those samples. They just had a lot of particulates that lead to a lot of clot and clogs. In addition to having that high failure rate, we had to either have a camera system do the inspection of the plates or a manual inspection. With the VBP, when we implemented that to those same workflows, that first pass failure rate dropped from that 30 to 40% down to 3%. And we didn't have to have that manual inspection or camera inspection because the data was presented to us and it gave us, for example, well, H3 had a clot. So we could just look at that report and knew what would need to be addressed when it came off the system. So then we have empty well. So very easy. Air has a very distinct flow curve, and so we're monitoring that. When we see that after so many milliseconds of aspiration, if that flow curve remains, we're able to detect that, hey, we're only aspirating air. Do you want to retry, maybe go lower in the well, or just report to the user, hey, there's nothing here. With the liquid air diagnostics, this is going from aspirating liquid and then we start pulling air, there's a lot of noise in the signal, disruption, and then an increase in the flow rate. So we're able to detect that. Now, in this case, there was a lot of bubbles before we made that shut off of the valve. We can set that as sensitive if you want. If you're more worried about just running out, setting it less sensitive like this is fine. If you want to catch any bubble or even small amount of liquid, we can do that as well. So then how do we take these technologies and actually put them to use in real live workflows? So the first workflow, we'll be talking about how we do the high throughput DNA purification, particularly using sbeadex Lightning and then pairing it with the Lynx. So once it's done with the incubation, this is kind of where we sit in the process. So you move the samples to the Lynx. We can use the pipette tool features of the Lynx to add all your beads, binding buffers, wash buffers, and then elution as well. And then with the elution, it could be heated or not heated. And then once that's done, we can put this core down. We pick up this 96 rod head and begin the actual process. So here's an example. This is sped up just so we can, be mindful of time and everything. But it just finished adding the beads and buffer, did a quick mix into that sample plate. Now it's going to load the magnetic rod head. Now it's doing the actual binding, mixing. So it's going to do this. And then once it gets done, it's going to go down, drop the magnetic rod head in. We're going to go collect those beads, move them over to that first wash plate, and now begin the mixing and wash process. Once it's done and done a sufficient wash, it's going to drop the magnet down back into that tip cone, collect all those beads, and then move to the elution plate. Again, this elution plate, in this case, was just sitting on deck, room temp, but it could have been heated as well. And so now it's doing a very rapid mix. And then once it's done with the mix, it will go down, drop the magnets again, pull those beads up, and get rid of the tip cone at that point. And then you would be left with your ready to go purified DNA samples. So the normal process takes about 5 minutes. In this case, we sped it up about 4x just to keep it tight for the presentation. So that is, a very simple protocol in terms of the sbeadex Lightning. The kit's great because of its simplicity, but then the ability to mix and match the pipetting with the magnetic rod in the same system. It really just allows that end-to-end walk-away for the customer and end user. So the next aspect or application that I want to talk about, how we use the Lynx, is for the Amp-Seq protocol, particularly focusing on the pooling and bead cleanup. So here's an overview of the Amp-Seq protocol. And again, I'm going to be highlighting the pooling and bead cleanup. I'm also going to show just a very generic example of what we could do for some of these other processes, like adding master mix to 384 well plates. One thing that I don't show, but would be a very normal and powerful application for that BBP head, is also the normalization. We're going to normalize a plate in about 60 seconds for a 96 well. So while I don't show it, this is another key aspect of that. So here's just showcasing how we can go in, we could aspirate using that 384 head, stamping out a low volume. What I like about this is it's simple, but it's showing how we can use a single tool as a basic liquid handler to do one of the steps of the process. And then we'll be able to change, and as you'll see later, have a different tool on this system that's doing something completely different. So we go from just a very simple liquid transfer or filling of plates with a reagent, in this case, nice colorful dyed water, but the performance and things like that for master mix at low volumes is something that we validated for a number of customers. But then we can go to a magnetic rod head and begin actually doing that bead cleanup step. So again, very simple process here, but the fact that you can do it without having either manual intervention steps or multiple tools needed, really just kind of gives an all-in-one solution. So for the pooling, what does that look like? It's a 384 plate that we're aspirating all 384 samples, and we're pulling them into a single well of a 96 well plate. So in this case, we're taking all of these samples, putting them into A1 of this 96 well plate. In this case, we would have, if we had 16 plates, each plate would go and fill up the first 2 columns of this 96 well plate. So that's going to be the pooling, and I'm going to show that and how that looks. And then additionally, we also do the bead cleanup. So we can load this magnetic rod head and go and do all of the binding of the DNA, go through all the washes through elution. So the VBP has that ability to independently control every channel. Another thing that we're really good at is non-contact dispensing. The reason why is we can essentially have an infinite blowout. So I can aspirate the full volume of any tip that we have and dispense 10, 20x that if I needed to. So in this case, what we're doing is we're aspirating just a couple microliters from every single well of this 384 well plate, which at this point is something that any 96 well pipette tool should be able to do. The next thing we'll do is we'll pull this post air gap just so we keep the sample up into the tip until we're ready to dispense. But this is where the 96 VBV stands alone. This ability to do this non-contact on-the-fly dispense and pool all of these samples into a single well is only something that the VBP is capable of doing when you're looking at a high-density channel head such as a 96. We're able to do this in about 90 seconds or less. I think this example is closer to 85 seconds, and that's from loading tips all the way through the dispensing. So very efficient. If you had to do a lot of these plates, we're going to be, anywhere from 4 to could be 12 or even 20x we've seen, depending on what you're doing for your existing process in that pooling. The next thing that we go to is for the Amp-Seq, we can do the bead cleanup using the magnetic rods. And so, again, it's a very simple process where we're just, in this case, just doing the binding and then going, transferring those beads into a downstream plate. It doesn't have to be super complicated, but the fact that we are able to use multiple tools, again, you could have had a pipette tool that did all the filling. If you had the plates coming into the system filled, you can see we have a robotic arm over here that could have fed plates in from a different system, that we can just leave the mag rods on and maybe have a dual arm and doing dual mag rod processes. So in this case, we're going down after we do the binding steps, and we're just doing that transfer into that next step. So again, the power here is that we have multiple different tools that can be combined to create a single walkaway workflow. So then it's just going to do the mixing. It mixes quite a while, so I won't show all of the mixing, but this is kind of what it looks like. So we've done VBP, we've done MCPA with magnetic rods and kind of highlighted those. One other aspect that we do, and we've done this particularly with LGC, is working with their high-throughput SNP genotyping, and particularly with transferring from 384 into 1536 plates. So the workflow that the Lynx is involved in is in that plate replication process. So right up here in kind of the early stages. So we're taking our 384 core, aspirating the replicates from a 384 well source plate, and then we're dispensing them into multiple 1536 well plates. When we look at that, what enables us to do this without tip guides and a lot of extra steps in the process is the linear motors. So all of our systems use linear motors, which are very precise. They allow excellent X, Y, and Z motion control. So we can easily line up over these 1536 round well plates, which, considering the tip size is almost the size of the opening of the well, you need to have that precision in order to do that. And then we have what we call our P-lips or passive locking interface plates. This just positions these plates into the same position every single time, so you have that reproducibility. So there's not any user error in terms of did I push it over, or where of a spring that maybe over time doesn't put it in quite the same place. So this just kind of eliminates that and gives us that reproducibility. So when we do that, it gives us the positional accuracy and we need in order to deliver those replicates. So this is just doing 4 plates, and we're just going into the first quadrant. But the ability with the system is we have validated working with LGC to aspirate up to 20 plates worth in a single aspiration, and then deliver 1 microliter to each quadrant of a 1536 plate. And then after that, we can go and run up to 3 more plates. So in this case, we were just doing a single 384 into 4 1536 plates, but we could do 4 384 plates into 20, up to 20 1536 plates. So kind of an overview of everything that I've kind of discussed today is, we really focused on streamlining the automation to accommodate multiple different types of applications. So not a one size fits all. And for some customers, they may only do 2 of these workflows, or they may do all 3, or they may do just 1 with the idea that they may expand later or have some other generic liquid handling needs. So in the case of the sbeadex Lightning, we really focus on utilizing our magnetic rod paired with our 96 pipette core to give that end-to-end walkaway for that process and allow customers to purify that DNA using the sbeadex Lightning in under 5 minutes. And we can tailor these throughput needs. So we have some customers that want max throughput, but the plates are already going to be pre-filled. So we do focus on dual arm systems. We have other customers that want, maybe one system that does multiple processes, and the throughput's maybe not quite as demanding, but it's walk away throughout those different processes. So with the snip line chemistry, again, we've got the linear motors, which is going to be true of all of our systems, but it's really important on this process and those passive locking interface plates to give that reproducibility, that high precision that's required for going into those 1536 plates and delivering accurately 1 microliter without having a large number of dropouts or poor accuracy from that bulk aspiration and dispense. So it looks like a simple process, but honestly, of all of the processes, this is probably one of the more challenging ones to do, just because there's a lot of low tolerance aspects to this process. When it comes to Amp-Seq, we've got, of course, the ability to handle all of the general pipetting, the normalization, and quant steps, but then really that pooling just is kind of game changing in how fast we can pool precisely for our customers, and then using the magnetic rods to perform the extraction and sample prep. That whole library construction process can be done on the Lynx. So really the benefits that transcend kind of all of the system is the automation itself lends to very little manual intervention throughout a workflow. We have a ton of flexibility based on whatever cores or deck configurations that you want to use for your process. And the system itself and these core options and things like that to handle multiple workflows is a relatively cost-effective solution for most of our customers. So we're not charging, significant amounts of money for those MCPA cores. And so a customer that maybe had to buy 2 systems in the past is essentially buying one with a 10,000 or less core. So very cost-effective our customers. And with that, I'll open it up for questions.
Okay, so yeah, thanks a lot, Toby, for that super interesting and insightful presentation. So as you just see, we now have a poll question coming up. So as you just learned from Toby, that the Lynx system is super flexible and you can do a lot with it. We would really like to get some insights also from you. So what are basically the automation features that are most relevant for you if you think about your genotyping workflow? So would that be total throughput that you can achieve in a day shift, or rather that you say maximum hands-off time and walk away is important to you, or is it more about flexibility, wanting both DNA isolation as well as a pooling or cleanup or NGS library set up on the system? So would be really great, yeah, if you can give us some hints on that. And with this, we would also like to just start our live Q&A session. So we got a lot of questions from you. So first of all, thanks a lot for that participation. That's always great. And so, yeah, just let's kick it off with the first question. So there's one question from the audience saying, first of all, that looks great. So that's a compliment for you, Toby. And then can it be integrated into LIMS system, and how does it do that?
Yeah, so yep, we have integrated with a number of different Lynx systems, and we know that we can integrate with Kraken as well. So there's a couple different ways that this works. We have a couple different APIs that we expose that can talk directly to the LIMS. So in some cases, the LIMS can actually start and stop a method if that's the desire of the customer, or it can be something more simplistic where the LIMS is passing off just the variables or the information for the run, the batch size, barcodes, things like that. And then our system takes that and translates that into the volumes, the variables, and sets up the work table, and then provides the user with a prompt to say, this is how you load the instrument for your particular run. They do that, they hit go, and it runs. So really, it's working through the API, but we have a couple different API options that allow quite a bit of flexibility.
Okay, perfect. Thanks a lot for that. And then we have another, or rather a few questions coming from one participant. And again, hi, nice presentation. I have a few questions. So first question would be, if I understood correctly, it could replace a magnetic bead extraction, such as a Kingfisher. Was it benchmarked against those kind of things or machines? Can you comment on that, Toby?
Yep. So yes, we have the magnetic rod head. So as you can assume, it works very similar to that type of extraction that's performed on a device like a Kingfisher. So, and we've actually done several side-by-side comparisons for customers with the Kingfisher, particularly in egg biotech. What we've seen is actually that we've had, because we have full X, Y, and Z motion, we can actually do some motions that allow us to leave less feeds behind. So our transfers are actually cleaner for our customers than what they're seeing with their traditional, whether it be Kingfisher or some other magnetic rod mixing technology. And additionally, you also get the benefit of adding not just the magnetic rods, but we can actually fill the buffers. We can prep all those plates kind of all in one step. And then as I kind of showed earlier in the presentation, on a Kingfisher thing or devices like that, typically they're not super integration friendly. There are some models that are, but we have the ability to slide load those tip combs, so we can just feed the tip comb and just keep running more plates, so we can actually maximize the throughput a little bit more. Yeah.
And from my perspective, from developing DNA kits, this is really the unique thing about the system, right? So that you have this integration of the MagWatt with the pipetting skills. And because this is most of the work you do with the Kingfisher, right? You need to fill all the wash buffers, you need to do the transfer of your lysates, right? So this is a quite tedious process. And as Toby just said here, you can really have a walk-away system, just placing your lyse samples and then walk away, and the machine does everything else. And especially as you can have two heads on it, you can maximize the throughput. And that actually goes a bit into the direction of the next question, that was, can the VPP do, or the VPP clot detection, would that allow as well to skip a centrifugation step after the lysis? So I think that goes towards, the transfer of lysates.
Yeah. So what I experienced, so that clot detection, with particulates and things like that in the wells, it allows for the detection of that clot, and then it stops and doesn't lodge that clot farther into the tip, and then it can perform that retry. So that retry, you have up to 5 that it'll retry. So it doesn't necessarily guarantee that you will clear it, but what we've seen is, compared to when I was in the lab, we had other liquid handling systems that had 30 to 40% failure rates depending on certain tissue types. Root tissue was a big one. Silk as well, because it could be overfilled into the plates. Like the sampling techniques were not as consistent for some of those. And what we saw is when we moved it to the VVP, we were able to reduce from a 30 to 40% failure rate to that 3%. So depending on what your extract looks like, your lysis, you may be able to. I would say it's probably tissue dependent or process dependent, but you're going to definitely have an improvement. And in some cases, you should be able to just go avoid that centrifugation step because of the clot detection. In addition to that, we can do things that are a little bit more bespoke, I guess, or based on your process. So one example is we have a process where we want to we go down, and if we detect a clot, rather than retrying and raising up and then retrying in the same spot, we can actually move over to the side or at a different position in the well, not just lower, and we can perform an aspiration at that point. One thing too is as long as we have consistent flow with that VVP, we're going to continue to aspirate. So like a syringe-based pipetter, you're pulling it back, and then once you pull it back, you're done with your aspiration, whether you got the volume or not. With ours, with the VVP, we're constantly monitoring the rate of flow in real time, and so what that allows us to do is continue to aspirate. And so maybe all the other channels are unblocked, no partial occlusions, anything like that. They're getting an aspiration flow rate of 100 microliters a second. But one is partially occluded, and it starts to flow and continues to flow at maybe 50 microliters a second or 20 microliters a second. So the other channels will finish earlier, and this one will continue to aspirate till it reaches its target volume. So there's some other things with that VVP technology that enable you to kind of get away with not having to have as clean of an extractor or sample when you're doing the transfer.
And I think I would also add what's super nice is the diagnostic function, right? I mean, I can tell from one of my own experience visiting a breeding customer once, they had a lot of failures in their downstream genotyping procedure, and we wondered what it was. In the end, it all came down to the very upstream homogenization of the sample, and because that was not monitored, right? There was no diagnostic for that. They wouldn't know why they would see the failures down the line, right? Where you could see, if you look at the plate, the seeds, for example, that are homogenized give the failures. This is something that a system like that would also help you to detect, right? To know if you can optimize your method then. Good. Then we have a bunch of questions on, all around kind of, handling and the interface. So basically a few questions like how is the interface? Can it be programmed by end customers, right? So can you program it yourself? And maybe you can comment on that, Toby.
Yeah. So in terms of the processes, so any of the processes that I mentioned here, we kind of have a way of doing things with the Lynx. So the first is any Lynx system is going to come with a number of methods and workflows that we provide for you based on conversations that we have with you. And so we use those as not only training, but kind of templates, because you're going to be familiar with your workflow. So if you can kind of see it in a visual format. The software itself is pretty simple to use. I have customers that have never had automation experience and some that are extremely well versed in automation, that can write methods during that training and installation period, when that's their maybe first exposure to the Lynx. It's very routine for customers to use the drag and drop commands to create that normalization, cherry picking pooling for the VVP, for the MCPA, doing serial dilution, stamping, basic transfers, things like that. All things that we would expect somebody with only a few days interaction with the instrument to be able to do. So a lot of drag and drop commands, even some of the logic that is more complex, you're able to use. In terms of the interface, it's kind of a Windows-based application, so pretty standard in that aspect. There is the ability to create custom user interfaces or GUIs based on your lab needs. And then for anything that's super custom or advanced that our software doesn't happen to have a solution for, we have a full C# editor that we can tap into in order to create something extremely custom. But I would say 95% of what our customers are doing doesn't require that, but that does give us that extra ability. Maybe you want a custom file output type and it has to look a certain way. We can do that.
Okay, nice. Then I have another question, and maybe this goes a bit more into my direction. So that is, do you have any experience with this technology with trees? I mean, first of all, as we showed a lot of technologies, I'm not 100% sure what technology that refers to, but at least I can make a quick comment for that on the DNA extraction workflow that we have with Lightning, and maybe just highlight a few things for that. So the special thing about the Lightning chemistry is really that we kind of created a very innovative MAC-bead-based purification that's extremely quick because we modified the binding step. And now the first step of the protocol is a combined binding and wash step. And by this, we only have a second wash with water, and we eliminate all other wash steps as well as a drying step. So efficiently comparing with any other protocol on the market, we cut away a few of the steps, enabling that super fast isolation. And another nice part about the technology is we made it kind of modular. So we have the purification as one part of the Lightning kit, and then we have a modular lysis, if you want to call it like that. So we have plenty different lysis buffers. So in total, at the moment, it's 6 different lysis buffers, and we're constantly developing more. And so as we're working for a long time in the ag-bio field, we have a lot of experience with all different type of plant samples, seed samples, livestock samples, with a lot of different buffer combinations. So although I don't know it by heart, I would say there's a very good chance that we have some sort of lysis chemistry that work for certain tree samples as well. And I'm sure we have some experience on that now, R&D, and I'm more than happy to discuss it further and find a good solution there for you. And if it was any of the other technologies, yeah, feel free to ask that later on after the webinar. Okay, what else? We have one question. If the Lynx system works with low retention tips, and what is the maximum and minimum volume it can work with?
Yeah, so we do have an option for low retention tips, so that's an easy one. The max and min volume is a little bit dependent on which technology that we're working with. So when we talk about the VVP, your volume range is 2 microliters to 1,250 microliters, where we have some customers that go a little bit lower than that, but that's the stated range, so where you're going to get excellent CV and accuracy with any sample type. When we go to the MCPA, the head swapping technology, it's a little bit different because it's going to depend on which core type that you're using. So the 384, which we also have a 96 version of that, that's capable of going 0.3 microliters up to 70. Then we have a 1 ml option, which is 1 microliter to a mil. And then we have a large volume, so 50 microliters to 5 ml. When you look at that tool itself, because you can swap these formats, the tool itself that MCPA tool could have a range of 0.3 microliters to 5 ml. just depending on which cores that you supply it on a system. So a pretty wide range. And happy to get more into the the QC data and share that after the call. We can send some information out if you're curious.
Okay, and then we have a bit more questions on the MagWatt technology and how that facilitates the throughput. So one question is, can you explain the key steps that are facilitated by the MagWatts? And a question going in a similar direction is, so basically, how does the throughput on a Lynx system in combination with the DNA extraction you showed compares to other solution on the market?
Yep. So in terms of the key steps facilitated, so really it's going to be when we're looking at the extraction side, the binding steps, moving those beads through the wash step and into the elution plate. So a lot of it's just the bead handling and particle moving, if you will. And then those mix steps, binding steps, and then just making sure we're getting a very good mix is very critical. That's one thing that we see with the magnetic rods. And then, of course, doing the bead cleanup step in some of those library prep, Amp-Seq, Flex-Seq type workflows, you have the ability to do that. When it comes to the throughput aspect, this is, I think, one of the questions why we put that poll question up there is it really depends. We have a lot of options here in configuration, so our system's wide open. But if you're, what I can say is we have some options that when you're using like sbeadex Lightning, for example, where we have more than 200 plates can be extracted on a single system in 1 8-hour period. And that's, a dual arm, walk up, load the deck, hit go, and then just change out the deck as needed. And, a run size may be 32, 33 DNA extraction plates per system. But then we also have smaller versions of that where you're running 8 plates at a time. And for those, because of the way that we can process using the magnetic rods and then kind of work in a sequential format rather than just working only in parallel, we're able to process these samples very quickly. So it's hard to give an exact throughput number because it really depends on what your goals are with the system. Is it to have one system that's focused on DNA extraction only, and we have 2 arms and we're working in parallel? Is it one that is a single arm, and how fast can we get through like a smaller batch size of 8, for example? Or is it something where we're using that BBP technology and that MCPA technology kind of in tandem, and to go and cover multiple workflows across the process? And so then that kind of determines how much space we have availability, and then working and using the 2 arms in what we call concurrent processing, but essentially using them in parallel. So like I said, on the high end, we're well over 250 DNA extractions in an 8-hour period on one configuration. But we can customize down from there. So just depending on size, cost, workflow, all of that.
No, I was just saying 250 plates, right? Because he said 250 reactions, and obviously,
plates,
yes.
Yeah.
Thanks a lot, and we are more than happy if you get back to us and tell us just what your needs are to give you more concrete numbers on that, and really calculate for you what kind of throughput you could achieve with the needs that you have, and how you would like to implement the workflow. And in the interest of time, maybe let's take one last question that probably is interesting to anybody that would be very interested in your system, and that is, can you give us any idea about approximate costs and lead time of the system? So
everybody's favorite topic, right? Like, I hear it. How much is it? So lead time's easy. So any of these systems that I talked about fall in our standard 4 to 6 weeks turnaround for delivery and shipment and installation. When it comes to cost, again, that's going to be dependent on configuration. We play with systems that can do this process anywhere from $85,000 US up to $350,000 US. I would say the 2 most common configurations that we're going to have with MCPA only, so doing like replication and DNA extraction, maybe 8 plates at a time. That system's going to run between 125 to 165,000, depending on the size of the instrument that you want for that. When it comes to the VBP technology, so doing more of that AMP-Seq, FlexSeq workflow, you're going to be in that 200 to 225 range. And then a dual arm system that can kind of do all of it. We're going to be having that conversation 275 to 300 is typically those. Of course, things can be modified, changed, but that's pretty good ballpark numbers for those 3 common configurations.
Okay, perfect. So I would like to, close today's session with that. First of all, thanks a lot for your time today. I would really like to thank LabRoots for hosting the event. As well, I would like to thank Toby and our collaboration partner, Dynamic Devices, for just giving that super exciting presentation and answering all that interesting questions. Before we leave, also, thank you for just being so active today and asking so many questions. That's always great. In case we have not been or we don't found time to answer some of the questions, as I said, we're happy to get back to you later on after the webinar, and we will address these questions. And as well, one last thing is that this webinar will be available on demand as well. So you can always go back and watch it again. You can share it with your colleagues or any other people that you may think that could be of interest to. And yeah, with this, I hope you will join us for any of the next or upcoming webinar sessions. And was a lot of fun and pleasure. And have a nice day. Thanks a lot.
Thanks, everybody.